Okay, my name is Wajahit Chima, and I'm going to be doing homework number 4, question number 1. So, question number 1 states that if x is greater than or equal to 0, and then the expected value of x equals n, then we have to prove that we have to show that the probability that x is greater than or equal to the square root of n is less than or equal to the square root of n. Okay, so the way we'll start this is we'll write that the expected value of x, this is just a general formula, equals the integral from negative infinity to infinity x f of x dx. Now, we're given that x is greater than or equal to 0, so we can close these limits a little bit. We can make the bounds a little bit smaller. And since the bounds are a little bit smaller, they're going from 0 to infinity, this area will be smaller as well. So this will be less than this area right here. So it'll be x f of x dx. And then further on, we're going to swap out the 0 bound with a square root of n bound. So square root of n is a constant, so it would definitely be smaller since it's a smaller bound. The area would also still be smaller, x of x f of x dx. And we'll say that x is a constant that's greater than or equal to the square root of n. So if it's greater than or equal to the square root of n, then the area under the integral would also be over here. The area of this integral will also be greater than or equal to the area of this integral right here. So we can take out the square root of n since it's just a constant. Keep the same limits, f of x dx, and this equals square root of n f x greater than or equal to n is less than or equal to n. And over here we'll see that the f x greater than or equal to n greater than or equal to the square root of n, we're just dividing both sides by the square root of n. So over here the square root of n cancels, over here is less than or equal to n divided by the square root of n. Any number divided by its square root is greater than or equal to just a square root. So using that simple process, we see that f x greater than or equal to the square root of n is less than or equal to the square root of n, and we have shown this proof right here. Thank you for watching.